Guys, today's video is on the third method that we're going to learn on how to solve quadratics, which is called completing the square. Completing the square is useful because when we cannot factor a trinomial of a quadratic or a binomial, then we're going to use this method. It could be a little challenging. I think it's definitely harder than solving by square roots. But before we do completing the square, let's recall a couple little information on how to factor a perfect square trinomial. Remember that when you have factoring, you need to add to get the b and multiply to get the c value. The magic numbers are going to be 4 and 4. And with these perfect square trinomials, you'll write it like x plus 4, x plus 4. But remember, the better way on how to write something that occurs twice is simply just x plus 4, but then squared. Same thing that's going on over here with the x squared minus 10x plus 25. You want to find two numbers that add to get negative 10 and multiply to get 25. That is also negative 5 and negative 5. Perfect square trinomials are always going to have the same number twice. So you're just going to write it as negative 5 squared, x minus 5 squared. This one is also a perfect square trinomial. Add to get 2, multiply to get 1. Those numbers are 1 and 1, both positive, and you can just write it as x plus 1 squared. So with these perfect square trinomials, the reason why we need this is because they are going to help us complete the square. We're going to factor in the middle of solving for completing the square. Let's look at number 1. If we're trying to solve this quadratic of x squared plus 16x minus 9 equals 0, you can't factor that. There are no two numbers that add to get 16 but multiply to get 9. So what we're going to do is we're going to solve this by what's called completing the square. Step 1 is to move the c value to the other side of the equation. That means it's going to be x squared plus 16x equals, and to move it over, we're going to do plus 9 to both sides. The next step here is called completing the square. That's pretty much the big part of it. What we're going to do is we're going to take half of the b value. The b value in this case is 16. And then we're going to take half, and then we're going to square it. Let's see what this equals. So we got 16 divided by 2 is 8. Squared makes 64. We're going to take that number and we're going to add it to both sides of the equation. X squared plus 16x equals 9. Let's add 64 over here. And then we're going to add 64 on this side. Step 3 says what we're going to do is now factor the left side. This left side, after we complete the square, is always going to be a perfect square trinomial. So again, we're going to add to get 16, multiply to get 64, and that is 8 and 8. So we write our perfect square trinomial as x plus 8, but instead of writing another x plus 8, we can simply just write it as squared. On the right side, we could just add these two together to make 73. Step 4, we're going to take the square root of each side, and also, if we can, simplify the square root. So taking the square root of both sides now, the square root of x plus 8 squared, what that does is that it cancels out the squared. Remember, squared cancels out the square root. So now we're just left with x plus 8. And on the right side, we have, whenever we take a square root of a number, don't forget the plus and the minus. 73 cannot be simplified. There is no perfect square that I believe that goes into 73. So we're just going to leave it like that. And the last step is to add or subtract to get x by itself. Again, I rewrote this to fit in the step 5. So in this case, to get x by itself, we're going to do a minus 8 to both sides. and your final answer would be x equals, and when you have this minus 8, don't do minus 8 from 73, because this 73 is protected by a square root. You can't do a minus 8 here. Leave the minus 8 on the side with the plus minus square root of 73. What the answer means is that we're going to have two solutions. One solution is going to be negative 8 plus the square root of 73, whatever that decimal is. And the other solution is negative 8 minus the square root of 73, whatever that decimal is as well. So there's two answers here, negative 8 plus the square root of 73 and negative 8 minus the square root of 73. Let's do another one just to practice these steps. We're going to solve x squared plus 6x plus 10 equals negative 49. Let's write that over here. We are going to move the c value to the other side of the equation. To do that, I'm going to move my 10 over. So we're left with x squared plus 6x equals a negative 59. And again, we're completing the square because this is not factorable. It's not going to give us nice numbers if we did factor it. Step 2, the important part of completing the square, is taking the b value, in this case is 6, dividing it by 2, and then squaring it. Doing that gives us 3 squared, which is 9. So we're going to add the 9 to both sides of this equation. Big thing that people forget is they add it to this side, but they will forget to add it to the other side. What this makes now, this makes a perfect square trinomial on the left side. Again, factor, add to get 6, multiply to get 9. That will be the same number, so both a positive 3. We write that as x plus 3, but instead of writing it twice, we'd make the squared, and then that equals negative 59 plus 9, which is negative 50. The next step, what you have to do, is take the square root of both sides. So if we take the square root over here, it cancels out the squared. So you're left with x plus 3 equals the square root of negative 50. Remember, we cannot do a square root of a negative number. It's not going to give us a real solution. So as soon as we have a square root of a negative number, we can automatically say there is no solution. If in fact this was, let's say, a positive 50 instead, then we would have to simplify the square root of 50 into, let's say, like 25 times 2. Remember to take the biggest perfect square that goes into 50, and that would be plus minus 5 square root 2. And then you would have to minus 3 over at the end to make negative 3 plus minus 5 square root 2. Again, that's if the 50 was positive. You would have to do all this stuff with simplifying the square root and then moving over the 3. Write down what questions you have on these two examples about completing the square. We're going to do one more in class where it looks like this, where the beginning A value is not 1. It's a little bit different. We might just have to take out a little GCF at the beginning. So think about any questions you have on completing the square. You do have to give your best effort on this stuff because completing the square in my case is probably just the most challenging because there's steps you haven't seen before and there's factoring involved. So try your best next class and we'll practice. Have a great night.